Factoring a cubic polynomial, a polynomial of degree 3, can be more complex than factoring quadratic polynomials, but it can often be done using a combination of techniques. Here are some steps and methods to factorize a cubic polynomial. 1. Check for rational roots. Use the rational root theorem to find possible rational roots. The theorem states that any rational root in the form of QP must have P as a factor of the constant term and Q as a factor of the leading coefficient. Test these possible roots by substituting them into the polynomial. 2. Synthetic division. If you find a root r, use synthetic division to divide the polynomial by xr. This will give you a quadratic polynomial. Factor the resulting quadratic polynomial if possible. 3. Grouping. Sometimes you can factor by grouping terms. This method is more applicable to polynomials that can be rewritten in a form where common factors can be easily identified. 4. Using the factor theorem. If f of x is a polynomial and f of a is equal to 0, then x minus a is a factor of f of x. Example. Let's factorize the cubic polynomial f of x equals x cubic minus 6x squared plus 11 x minus 6. Check for rational roots. Possible rational roots are factors of the constant term, minus 6, divided by factors of the leading coefficient 1. So the possible rational roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Test possible roots. Test x equals 1. f1 equals 1 cubic minus 6 times 1 squared plus 11 times 1 minus 6 equals 0. So, x equals 1 is a root. Synthetic division. Divide f of x by x minus 1. The quotient is x squared minus 5x plus 6. Factor the quadratic. Factor x squared minus 5x plus 6 equals x minus 2, x minus 3. Combine the factors. Therefore, the factorization of fx is such that fx equals x minus 1, x minus 2, x minus 3. Let's do another example. fx equals x cubic minus 5x squared plus 3, x plus 9. Step 1. Check for rational roots. First, we use the rational root theorem to find possible rational roots. The possible rational roots are the factors of the constant term 9, divided by the factors of the leading coefficient 1. So the possible rational roots are plus or minus 1, plus or minus 3, plus or minus 9. Step 2. Test possible roots. We test these possible roots by substituting them into the polynomial. For x equals 1, f1 equals 1 cubic minus 5 times 1 squared plus 3 times 1 plus 9. Not equal to 0. For x equals minus 1, f of negative 1 equals negative 1 cubic minus 5 times negative 1 squared plus 3 times negative 1 plus 9 equals negative 1 minus 5 minus 3 plus 9 equals 0. So, x equals negative 1 is a root. Step 3. Synthetic division. Since x equals negative 1 is a root, we use synthetic division to divide fx by x plus 1. The quotient is x squared minus 6x plus 9. Step 4. Factor the quadratic. Now, we factor the quadratic polynomial x squared minus 6x plus 9. X squared minus 6x plus 9 equals x minus 3 squared. Step 5. Combine the factors. Therefore, the factorization of fx is fx equals x plus 1, x minus 3, squared. We factored the cubic polynomial x cubic minus 5x squared 3x plus 9 by finding a root x equals -1, using synthetic division to reduce it to a quadratic, and then factoring the quadratic. The final factorization is fx equals x plus 1, x minus 3, squared. General form. For a cubic polynomial x cubic plus b, x squared plus c, x plus d, if you find a root r, you can write as cubic plus bx squared plus cx plus d equals x minus r, x squared plus b, x plus c. Then, factor the quadratic x squared plus bx plus c if possible. Summary. Factoring a cubic polynomial involves finding roots, using synthetic division, and factoring the resulting quadratic polynomial. The rational root theorem and synthetic division are powerful tools for this process.
Thank you for watching. Like, share and subscribe.